All right, so let's talk about finding the surface area of a prism again, and then we're going to notice how the formula changes when we find the surface area of a pyramid. All right, so here we have a square prism. Notice that the square base here is going to be exactly the same as the square base on the top, right? We would actually call this a rectangular prism. I don't think they call anything square prism, but because all the sides technically are rectangles, and so anyway, and any one of the rectangles could be the base. So we got 8. Oh, this actually isn't a square because this side is 8 and this side is 10. I said that backwards. So this actually is a rectangular prism. Get wrecked, son. There we go. Okay, so that's actually a rectangular prism because that's not even a square. All right, so we use our formula for the surface area, which is the two bases plus the lateral areas, which is found by the perimeter times the height. So if I look at the net here, the surface area is the area of all the rectangles, all 6 rectangles going around, right? So if I unfold it from 3 dimensions to 2 dimensions, that's going to look like this net here. And it's kind of color-coded so you can see where the base is and the perimeter and stuff like that. All right, so I want to find out first, what's the area of this base? And I know I'm going to have another base up here on the top as well. Those are going to be congruent, right? Because it's the same base here as we have up on the top, right? Okay, so the base is going to be 10 times 8, which is 80. So it's going to be 80 units squared, whatever our units are. And then the perimeter is going to be the distance all the way around. The reason we want to know the perimeter is this blue line here, the perimeter, the sum of all 4 sides, is going to be the same as this blue line here. It's just kind of unfolded. And it's because each one of these faces, the lateral rectangles, the lateral areas, faces, are all going to match up with the sides here. So we have 10, we have 8, and then we have 8 on the other side. And then we have 10 on the other side as well, right? So add them all together, it's going to be 20 plus 16, which is 36. So our perimeter is 36. And that's going to be the distance of the lateral rectangle. So the lateral area is the sum of all these rectangles together, and we're going to find its area. Next thing I need to know is the height. So the height is going to be the distance between the two bases. So from the top base to the bottom base, that distance, they're on parallel planes, and those planes are 12 units apart from each other. So that's this area right here is 12, this length. So to find the total, that's our height, which is 12, right? So to find the lateral area, I multiply the perimeter, which is the width of the lateral surface, multiplied by the height, the distance between the two, and that's going to give me the whole area here. So that's going to be 36 times 12, which I believe is 96, or no, 432. I don't know what I was doing. That was a different problem I was thinking of. So 432, let me double check that. Yeah, I mean, that makes sense because 10 times that would be 360. Then 2 more is going to be 76 plus 360 is, or 72 plus that. Yeah, okay, so it does make sense. But I'm going to go ahead and get out the calculator because we're probably going to need it for something else anyway. So I'm going to double check that. So 36 times 12, yeah, 432. Good. All right, so that's the lateral area. This is going to be 432. Okay, and that was found with the perimeter of 36 and the height of 12. Okay, cool. All right, next thing we want to do is find the surface area. So the surface area is when we take the lateral area, the perimeter times the height, and we add the two bases. So we said that the area of the base was 80, and the area of this base is also 80. So we're just going to do 2 times 80, which is 160, and add that to our lateral area. So let's go back to our calculator. So our value plus 160, which is going to be equal to 592. It's my dyslexia showing up. Ooh. Yeah, it is 160 because it's the two bases. So yeah, that is 592. Not sure what I did there. Okay, 592. So that was just a review of yesterday. So there's the surface area of a prism, a rectangular prism. So how does this change when all of a sudden we are looking at the surface area of a pyramid? So let me drag my first one, which was hiding the whole time. So let's pyramid this whole thing. So to make a pyramid, instead of going to a parallel, on a parallel plane, we have a congruent base. We go to a single vertex here, a single point. So now we have a rectangular pyramid. That's going to bug me. I'm going to have to get over it. So anyway, it's not a square pyramid. It's actually a rectangular pyramid. Boom. try it again. There we go. All right. So how does that change our overall formula? Well, how does that change the net? So what is the net going to look like now? So let me pull the second one up here. There we go. So now our net, instead of having rectangular lateral surfaces, now we have triangular lateral surfaces. So how does that affect the formula for the surface area for the lateral area? Well, if we're dealing with the triangles instead of the rectangles, that's going to be half of the area, right? So instead of wanting, I guess I will use blue. Okay, yeah. Instead of wanting the whole rectangle, which was the perimeter of 36 times 12, we only want half now. So notice how this triangle is half of the other two, and this one is half of that one, and then we got half the area here and half the area there, right? Because the area of a triangle is half the area of the rectangle, right? If they have the same base and the same height. So when we do our formula, it's going to be half of the base. Let me pull this out here. So the base is still going to be the same, right? So our base is the same, which is still 80 because it's 8 times 10. So the base is still going to be 80. The perimeter, the distance around, we still need that. That's still going to be 36, right? Okay. The height, now the height is different though, because our height used to be 12. Now we have to deal with something called the slant height. So it's not the actual physical height here. So the physical height we'll use for volume. So keep that in mind. So that's the orthogonal or drop perpendicular distance from the top vertice to the base. Okay, that's the actual height. But now what we want to know is the slant height. So slant height is going to be the height of the triangle on the lateral surface. So one of these triangles that's on the side surface here, the lateral surface, we want to know the height of that triangle, and that's going to be the height that we have that we're going to use to calculate for the actual for the lateral area. So let's assume that that's 12. So we took this and we kind of dropped it down a little bit. It's still the same length of 12, but now the height is going to be a little different. So the lateral area, which we use a script L for, cursive L, is going to be 12. That way we can see the difference in the formula. All right, so our height is now going to be written as a script L, a cursive L, which is going to be our slant height, which is, we're going to keep it still 12. All right, so now the lateral area, we do 36 times 12, but now we have to divide it by 2 because we're dealing with triangles instead of rectangles. So that's going to be half of 432, which is 216. And it should make sense why it's half, because we're dealing with triangles instead of the rectangles with the same base and the same height. All right, so find the surface area. We have the lateral area. Now we have to add the bases. But what's different about a pyramid? How many bases do we have? We only have one base because we no longer have this base on the top, right? So what we need to do is just add the base on the bottom because we don't have that top base anymore. So that we said was 80. So add 80 to 216, which should give us... that's not right. Yeah, it's because I calculated the other one wrong. So that's going to be 296. Yeah, so 296. Okay, so when we add 80, the one base to the lateral area, that's going to give us 296. Notice the difference between these two. So the lateral areas are half. The total surface area is half because we added half as many bases. So what's the relationship between the surface area of a pyramid and the surface area of a prism? Excuse me. Well, as long as they have the exact same height, the relationship is 1/2, which is pretty cool. And we can actually see that in the formula as well, which is the last thing I'm going to show you. So the formula for the surface area of a pyramid is one base instead of two bases, right? The perimeter times the height. But now our height is a slant height. We have to be careful because sometimes that's going to change the value, okay? And then we divide the lateral area by 1/2 because instead of base times height for the rectangle for the lateral area, now it's base times height divided by 2 because we have triangles for the lateral area. And that's it. So we're doing basically the same thing we did yesterday, but now our formula has been adjusted to exactly half. Notice that the surface area of the pyramid is half of the surface area of the prism, which is pretty cool. I've actually got kind of a cube, a pyramid inside of a cube that I constructed with 2 different colors, so you can actually like visualize all that stuff. And I think I've shown it to you guys before, but It's stuck at school, so I couldn't even like take a video of me like demonstrating it or anything like that. Anyway, I know it sucks, but I think this, you guys can definitely get the idea of what's going on. But that was it's a manipulative that I created that you could hand it to a preschooler, and they could tell you the ratio of the two areas is half, and then it also kind of demonstrates it, proving it here, which is even cooler. But it just kind of intuitively, your gut feeling will tell you whenever you see how I put it together that it is exactly half, and it actually is. So here we have another diagram. We'll go through it real quick. So this is a square pyramid or rectangular pyramid. Well, the base is a square, so we can call that a square pyramid. Our slant height here is going to be in purple. That's 6 inches, and it's a square, so all of them are 5. So the area of the base is going to be 5 times 5, which is 25 inches squared. Our perimeter is a distance all the way around, so 5, 5, 5, and 5. That's going to give us 20 inches. Slant height is going to be our 6. Okay. Lateral area. So for find the lateral area, we have to take the perimeter times the slant height divided by 2. Perimeter times slant height divided by 2. So 20 times 6 divided by 2. Well, when we do that, we can actually divide one of these by 2 first. So 20 divided by 2 is 10. 10 times 6 is 60. So you can, just a trick to be able to do that in your head, or just put it in the calculator. It doesn't matter. All right, so if the lateral area is 60, to find the surface area, we just have to add the one base. And we only have one base, which we said had an area of 25. So 25 times 60 is going to give us, or 25 plus 60 is going to give us 85 square inches, or inches squared. You got this. Okay. Something like off there that I want to delete. Okay, so let me show you what happens with a cylinder and a cone. It's pretty much the exact same thing. So here's our cylinder. We have our base. Our base is congruent, obviously, with a cylinder. Anytime you see a circle, a shape that's not a rectangle, that's going to be your the shape of your base. So anyway, it's got the same circle and congruent circle on a parallel plane above it. The area of the bases are both going to be the same. Oops, I moved it. So anyway, that's our cylinder. We've got a radius of 5, a height distance between the two bases of 8. So let's use our formula for the cylinder. The area of the base is going to be pi times radius squared. So 5 squared is 25 pi. Make sure you don't forget the pi. We'll leave it in terms of pi because it's precise and exact. That's how we like it. Circumference is going to be 2 times pi times radius, which would be 10 pi. The height is the distance between the two, which would be 8 in this case, between the two bases. The lateral area, so here's our net of our circle. If you notice these 4 points here, those 4 points, if I rolled this and unrolled it, would line up with these 4 points here. And this 5th point is actually the same as the 4th point when we wrap them around, which is kind of cool. All right, so the lateral area is just going to be a big rectangle. It's just rounded because it's following, the edge of a circle. And so the perimeter of the circle, which is also known as the circumference, is going to be the width of our lateral area, which is 10 pi. So that 10 pi is going to be the exact same. I learned a code. Alt 227 is the code for pi. I know, I'm such a nerd. So that's going to be 10. And then the height of the lateral area is the distance between it, which we said was 8. Okay, so lateral area is going to be 8 times 10 pi. Struggle bus. I don't know what's happening. There we go. Anyway, is 8 times 10 pi, which is 80 pi. So our lateral area is 80 pi. And then to find the surface area, we just add the two bases, which each one of those is 25 pi. So that's 50 pi plus 80 pi. It's going to be 130 pi. All right, so how does all this change when we go from a cylinder to a cone? Well, as you can imagine, the relationship between a cylinder and a cone is exactly the same as the relationship between a square and a prism, or a pyramid and a prism. It's just going to have lateral area that's a bunch of triangles now, and we have one base instead of two bases. So we'll go through this real quick. I'll go ahead and actually pull up the the new net here. So our net now is going to have a bunch of triangles. Now I just drew 4 triangles, but if we actually like partitioned this up into infinitely many points and connected each point next to it to a point opposite over here, they would be a bunch of triangles, but they'll be infinitely small. It's kind of like a thought like calculus or something like that. So this height here is actually going to turn into the exact same height as the triangles. Those are going to, as they kind of, these points kind of shrink and get closer and closer together as they approach infinity, as they approach 0, I suppose, or whatever, they're going to become the exact same length. So don't let that bother you too much. But basically, if we unroll a cylinder, a cone, it's going to be a bunch of triangle slices. Which is kind of cool. So our formula is going to be exactly the same. It's going to have a base of 10 pi with a height of 8, but now we're dealing with a bunch of triangles, right? So it's going to be a base. Our base is still 25 pi, right? We got one base, just not 2. The circumference is still going to be 10 pi. We still need that. That's the distance around. That's going to be the width of the lateral area. The height is going to be a slant height now. We're going to let that stay the same. We're going to let that be 8. They'll give it to you in the problem, so if it does change, if we raise it up, then it would be longer. Lateral area, so that's going to be 10 pi times 8, but then we divide it by 2 because we're dealing with triangles. So that's going to be 40 pi. So notice that it's exactly half of the lateral area of the cylinder, because this had rectangular sides, this has triangular lateral areas. Okay, lateral surfaces. Then the surface area, we just add the one base to it, which is 25 pi plus the 40 pi, which is 65 pi. Notice 65 pi is exactly half of 130 pi because it has the same relationship as we saw between the prism and the pyramid as we see now with the cylinder and the cone. So the formula is exactly the same, except it's half, right? So we have one base instead of 2 bases. Now, instead of perimeter, we're talking about circumference because the perimeter of a circle is called the circumference, all right? And then instead of the height, we deal with the slant height, so we got to be careful. Sometimes it's different. We want to know the height of the triangles of the surfaces on the side, not the actual physical height, which we'll use for volume, which is the distance between the base and the vertice on the top. And then we notice we divide this by 2 instead of just keeping it the same because we're dealing with triangles instead of rectangles. That whole really cool visual illustration here. Oh my gosh, I just want to do it again. That is so dope. Wow. Okay, anyway, mesmerize. So let's go ahead and do number 1 now. So on number 1, if you have your assignment, we have a square pyramid. So if we notice we got the lateral surfaces are all triangles, so it's a square pyramid. The sides here are both 6, so the net would look something like this. I'm going to show you the net on a few of these, but you definitely don't have to draw it. I just think it helps us explain and understand what's going on with the formula and why the formula works, because we can visualize and see each part of the formula. So first thing is we want to find the base. So 6 times 6 is going to be 36 and meters squared. Notice it's not 36 pi because we're not dealing with the circle, right? It's not pi times the radius squared. It's just the base times height, okay? So saw some of those mistakes on the homework as well. Perimeter is going to be the distance around. So 6, 6, 6, and 6. It's okay because there's 4 of them, not 3. That's going to give us 24 meters. Okay, it's not square because perimeter is a one-dimensional unit instead of 2. And that's going to give us the width of the lateral surfaces, which is 24 meters. The height, the slant height here, is the height of one of the triangles of our lateral surfaces, which is 8 meters. Then our lateral area, we just take the perimeter times the slant height. So the perimeter, which is going to be the width of the lateral surfaces, all put end to end, times the height of one of those triangles, which is 8. So divided by 2, right? So that's going to be 24 times half of 8, which is 4. So that's going to be 48, and then another 48, which would be 96. That was a 96 I was thinking of earlier. Let me confirm that, because apparently I'm doing something weird. All right, so we're going to have, or did I use the base? Yeah, so 24 times 8, which is equal to 192. Okay, I don't know what I did. That's okay. So our lateral area is 192 square meters, and then to find the surface area, all we have to do is add our base. So that's 36 plus that, which is going to be 228 square meters. All right, here's our formula. Let's make sure we understand what happened. So the lateral area is the perimeter, which is the width, which was 24, times the slant height of 8 divided by 2. divide by 2 because they're all triangles. And then we add the one base this time because we have only one base because we don't have another one on the parallel plane above it. Yeah, there's no parallel base up there, right? We only have one base. All right, number 4. So on this one, first we got to solve for x and y. So it's kind of in there and it kind of clues you in. So on this one, if this is, I think the word is, it's not oblique. I'm thinking it's oblique, but anyway, if this is actually centered here in the middle, then we can assume that this side here is going to be, if it's actually in the center, it's going to be half of the length of 5. So if this length here is 5, then this part, so essentially we're asking is, are all the lateral surfaces going to have equal areas? So actually they don't have to be. I don't think they have to be because they would all have the same. I'm thinking volume. Okay, so anyway, it does have to be an oblique polyhedron for the formula to work. If it's not, the surface area formula I don't think works, and then the volume formula does. I could be wrong, but I'm pretty sure I'm not. Yeah, I'm not. Okay, cool. So if this is 5, then this value x is going to be half of that value. Again, following that assumption that it's oblique. Okay, so that would be 2.5 meters. Okay, and then, ooh, maybe actually it would still work. It would just be a trade-off. Oh, that'd be so cool. Huh, anyway, cool math to think about for later. All right, y. So once we know this is 2.5 meters, we want to solve for the value of y. Well, if you notice, we have a right triangle here because this is orthogonal to the base. So to do that, we have to do the Pythagorean Theorem. So we're solving for the hypotenuse. We have 2.5 and 10. So that's going to look like this. So 10 squared plus 2.5 squared is equal to y squared. When we put that in the calculator, we end up with 106.25. And then we take the square root of that, which gives us an answer of 10.3 meters. Okay, so that's the slant height here. So that is the same as the slant height. So you can go ahead and fill that in down there as well. You'll notice it's listed twice on the answer bank. Now we want to find the base. So the area of the base, it was a little busy before, so I moved it off here. But the area of the base, which is our square here, is going to be 5 times 5, which is 25 meters squared. The perimeter is 5 times 4, right, which would be 20 meters, not squared because it's a one-dimensional unit. Then to find the lateral area, we multiply the perimeter times the slant height. So 20 times 10.3, but then we divide it by 2. Which is actually kind of nice because we can go ahead and divide the 20 by 2, which is 10, and then 10 times this is just going to move the decimal over once, right? So it should be 103 meters squared, and it is. Then to find the surface area, all you have to do is add the one base, which was 25. So 25 plus that is going to be 128 meters squared. All right, number 7. This one, just find the lateral area. So the only last step you'd have to do would be to find the area of the base. Which you'd have to do it based on an apothem or actually central angles and trig, which becomes kind of a nightmare, and I don't want you to have to get into all that. So just find the lateral area, or I would have given you the base in the first place. All right, so the perimeter, if this is a regular polygon, 5 sides, so pentagon, so this is a pentagonal pyramid, would be 4 times 5, which is 20 meters. Lateral area is 6 meters, so to find slant height is 6, so lateral area we multiply them, so the perimeter times 6, 4 times 6, then we divide it by 2, so that's going to be half of 24, or no, sorry, that's 20, yeah, so 10 times 6 is 60. Alrighty, so 60 meters squared. All right, number 9, this is actually a really cool problem. Because we have a kind of a composition of 2 different shapes. So on the bottom, we have a prism, and on the top, we have a pyramid. We want to find the lateral area. Well, we should be able to do this, right? And if I just left you alone, could you do it on your own? How would you break down the problem, I kind of did it for you, but how would you break it down in order to be able to find out what the total surface area is? Well, can we find the area of the pyramid, surface area for the pyramid, and then add the lateral area of the prism? Yes, and that'll actually work. So what is our perimeter? So we have 8 and 8, so 8 times 4, so it's going to give us 32 meters. So 32 meters is our perimeter. Notice that's the same perimeter for the pyramid as for the prism, right? Because those are going to be exactly the same. Okay. All right. So next thing is slant height for the pyramid. It looks like that's going to be 6 meters. The lateral area we multiply. So 32 times 6 divided by 2. So 32 times 3 would be 64, and then 96. So yeah, 96 square meters. And that's going to be the lateral area for the pyramid. So that's like the roof on top if this was a building. Now we need to find the lateral area for the prism and add the one base, right? So the area of the base is 8 times 8, which is 64 meters squared. So we could have said that was like the same for the base for the pyramid, but we didn't add that base because it's actually covered up. So it wouldn't be a part of the surface area. If we took those two parts apart, then you'd have, you'd have 2 more bases you'd have to add, but that's not what we're doing. All right, so the perimeter is still going to be 32 meters. The height in this case is going to be 5. That's going to be the height of our lateral area. And to find the lateral area of the prism, we have to multiply the perimeter of 32 times the height of 5, but we don't divide by 2 this time because we have rectangles, right? Because it's a prism. Okay, so hopefully you remember that. So that's going to be 16 times 10, same thing, which is 160 meters squared. So I halved that and doubled that because it made the math easier. Anyway, because, yeah, math. All right, so what's a total? We have the lateral area for the pyramid. We have the lateral area for the prism. And then we need to add one base to it. So add these together. 96 plus 160 is going to be 286 plus another... plus the base. So that's going to put us at 250, 320. Did I do that right? That's what calculators are for. All right, so 160 plus 96 plus the base. There's only one base on this one, 64, is 320. Okay, so I did do it right. And that should be on your answer bank. All right, last one I'm going to do with you is number 13. This video is going a little long, so sorry. You're probably watching it in parts anyway, working on the assignment and going back and forth. That's how I would do it. All right, so on number 13, so for this one, we have a cone, right? The circle is going to be our base. I can move that out of the way so it's not so annoying, so busy here. So first, let's solve for the value of x. Well, we have 13, so half that's going to be 6.5 if that's an oblique one, which we're going to have to assume it is. Otherwise, I don't think the formulas work. But I'm not sure on that because it might actually average out, even though these triangles would have less area and these would have more. So I bet it does average out, kind of like what happens with a trapezoid. But anyway, cool stuff. We're not going to get into ones that are non-oblique, even though that would be like super cool. Whatever, maybe next year. All right, so we have 6.5, we have 10, and then we got to solve for the hypotenuse. So we're going to use the Pythagorean Theorem. So we're going to do 6.5 squared plus 10 squared, which is 100. And then we're going to take the square root of that. So caret 0.5, which is equal to, all right, 11.93 if we round. So 11.93 centimeters. Now we want to find the area of the base. Now 6.5 is going to be our radius, so the area of the base is going to be 6.5 squared times pi. So remember, radius squared times pi. So we just need to square 6.5. So 6.5 squared, which is going to give us 42.25. So 42.25 pi centimeters squared. For the perimeter, we just do diameter times pi, which is 13 pi, or 2 times the radius, which again is 13. So 13 pi centimeters, not squared because, again, it's one-dimensional length. When we unravel it, you'll notice it's one-dimensional. Slant height. Slant height, we actually just solved for that. That was what x was, so that's going to be 11.93 centimeters. Then the lateral area, that's going to be all these triangles, right? Because we unwrap a cone, it's going to be a bunch of triangles that have like an infinitesimally small width. But they're still triangles, which is pretty cool. So we do base times height divided by 2. Well, our base here is going to be the perimeter of 13 pi. The height is our slant height of 11.93, and then we divide it by 2. So basically 6.5 times 11.93. which gives us 77.55, I think is what we round to. Yeah, on the answer bank. So 77.55 pi centimeters squared. Then to find the surface area, so we did the lateral area. We just have to add the one base, which was this value here. So we're going to take that and add them together, which gives us 119.80, kind of showing our sig figs here, pi centimeters squared. And that is it. Just under 41 minutes. So that was a lot of fun for me. It took a ton of time to put all that stuff together. But I hope you guys enjoyed it, and I hope you guys are getting it. This is definitely the more important part. The other stuff we've been doing in the unit is kind of just background information in order for us to be able to find the surface area of all these different polyhedrons. So there's only one more thing that we have to do, which will be spheres and hemispheres. We will do that. Oh my gosh, I actually forgot what day of the week it was. That's embarrassing. We will do the last part on Monday. So, and then we'll take the practice test on Tuesday. So make sure you get caught up on over the weekend. A lot of you guys are behind. So let's try to get caught up so you can finish the unit together when we do the practice test, and I'll post the solutions to that as well. Anyway, so I will see you guys later.